We just launched a new task manager. On the back end, it is completely flawless. It features a zero-latency application programming interface, or API, meaning data requests are processed and returned instantly. The database queries are optimized down to the millisecond. Then a real person logs in. They try to create a new task, but they mistype a single date in the input form. The interface freezes. The data they spent 3 minutes carefully typing vanishes. The person is left staring at a dead end, with no active buttons and no instructions on how to recover. To understand why this happens, look at this internal developer reference. It defines UI, or user interface, as the visible layer of the software. As shown in this list, it encompasses the layout, the buttons, the forms, and the typography on the screen. But look directly below that. UX, or user experience, is how well the product actually works for the person using it. It dictates the mental effort required to complete a task, their confidence in the system, and their ability to successfully recover from errors. If a person cannot successfully navigate a screen, the feature is broken. A highly optimized server query does not solve the problem if the interface fails the human being trying to use it. Let's rewind the development process to see how that dead end was built. To speed things up, the software engineer relied on an AI coding agent, giving it a basic, lazy prompt: build a dashboard. This guideline document illustrates why that fails. Look at the prompt comparison here. Coding agents default to generic interfaces. A proper prompt defines the user's specific goals, exact states, and clear rules for the visual hierarchy. The developer in our scenario designed exclusively for the happy path, the rare sequence of events where the user types everything perfectly, and the server responds immediately. They ignored everything else. We call those alternatives screen states. You must plan for loading delays, validation errors, empty data fields, and AI processing time. Look at the rule explicitly stated right here. A screen is incomplete if it only handles the ideal successful case. Building resilient software means designing for the moments when things break. Anticipating missing data and human error is the architectural difference between a generic layout and a functional tool. Returning to our broken task manager, let's analyze the only feedback the system provided: a tiny red box that simply said error occurred. It offers zero context and zero instruction. This section of the manual shows the standard for useful messaging. Notice the contrast. A correct error message plainly explains what went wrong, like missing required fields, and tells the user precisely what actions they need to take next to fix it. But the text was only half the problem. Zooming out to the overall user flow, the person was paralyzed because every text block, input field, and link on the screen was treated with the exact same visual weight. This layout guide breaks down the solution. To prevent user paralysis, developers have to put important information first. Related items need to be grouped together. Primary actions must be instantly obvious, and unnecessary clutter has to be stripped away. Structuring a layout this way is not an artistic choice. Clear communication and a logical visual hierarchy are critical navigational tools required to keep the user moving forward. Here is that same feature, rebuilt. By giving the coding agent a highly specific prompt, mapping out the full flow, and integrating forgiving error slates, the user glides through the workflow. When they make a mistake, the system gently corrects them and keeps their data intact. As this document clearly states, developers are not required to instantly become award-winning designers. But there is a minimum standard. Scanning down this list, developers must ensure the user can understand the screen, main actions are visible, flows make sense, and errors are handled gracefully. We enforce this because of the core philosophy shown right here at the bottom of the page. Good UI/UX is not decoration. It is part of solving the problem. The true test of a feature happens before a single line of code is written. Ask yourself, if the API goes down or the data is completely missing, will the person on the other side of the screen know exactly what to do next? Treating a user's psychological experience with the same rigorous logic you apply to your back-end infrastructure is exactly what separates someone who writes code from someone who builds products.